nå får se, støtter opp om undervisningen i faget grunnleggende databehandling ved NKI, Datahøyskolens ADB-kandidatstudium. Dette faget gir ett vekttall ved Datahøyskolen. Interesserte kan følge undervisningen ved å skaffe seg studiematerielle og løse innsendingsoppgaver, som sendes til skolen, enten som brev i vanlig brevundervisning, eller gjennom konferansesystemet ECHO. Det programmet du nå får se, inneholder et intervju med William Gates.
God dag. Vi skal nå få et intervju med William Gates. Han er grunnlegger og leder av Microsoft, en av de største programvarehus i verden. Han har vært med på å utvikle og lansere MS-DOS, som er det ledende operativsystem for mikromaskiner i dag. Og han har også lansert den første suksessfulle BASIC-kompilatoren for mikromaskiner. Han er et av de fremste autoriteter i EDB-verdenen i dag når det gjelder utvikling av maskinvare og programvare for mikromaskiner. Og da sier vi velkommen til William Gates.
William Gates, welcome to this interview. In Norway, Microsoft is most known for the operating system MS-DOS. What is the true story behind why IBM chose MS-DOS, not CPM, for the IBM personal computer?
Well, when IBM was trying to design their PC, they were actually thinking about the home market. And at that time, 1980, there were a lot of machines. The Apple II with our BASIC, the Radio Shack with our BASIC, the Commodore with our BASIC. The CPM machines were about 20% of the market. And when IBM first came to us, they were thinking of doing an 8-bit computer like the other computers. And they just wanted our BASIC. And we convinced them that they should be more ambitious and build the first 16-bit computer, which they did. Then, because it was going to be more powerful, we decided that we should have a disk operating system. And I actually sent them down to Digital Research. I called up Gary Kildall and sent them down there to see if Gary had developed his 16-bit version. Unfortunately, he didn't talk to them because they wanted a non-disclosure, and he was gone, and his wife didn't want to sign it. In any case, we decided that we should develop that ourselves and use that as an opportunity to get in and do a better operating system. And so when we finally submitted our proposal to IBM a month later, we included MS-DOS. In fact, we were very lucky to find a piece of work that a guy named Tim Paterson, who was in Seattle, had already done, and we hired him and used his previous work in order to build MS-DOS in the very tight schedule.
Is it true that they called this operating system quick and dirty operating system, QDOS?
Yeah, actually, Tim had a couple names for the work he had done. 86-DOS and QDOS were two of the names he used. We pretty quickly renamed it MS-DOS when we picked it up.
Okay.
Would you say then it was an accident that it was MS-DOS that won and not CPM? I mean, like, had Gary Kildall been there, would then CPM have been the system chosen and not MS-DOS?
No, we decided it was a mistake to refer that business to Digital Research. And because of our key role in the design of the hardware, I mean, you know, I picked the character set, we picked the graphics resolution, and it was very tricky because we had to integrate a BASIC and ROM. The machine had to be able to run without the disk, and it had to be able to run with the disk as well. And because of the tight time frame and the fact that they hadn't done their 16-bit version of CPM, then it was clear IBM was going to choose us first. Now, actually, the story is a tiny bit more complicated because even when the machine came out, although MS-DOS was the first operating system for it, IBM also offered CPM86. By then, Digital Research did get theirs done. They were about 6 months later. And so, in fact, there was a period of several years where nobody knew which the standard was. I was going around promoting MS-DOS, and it was companies like Victor that people don't even remember as much now, were actually more dedicated to MS-DOS. And so after a couple of years, it became clear. People always think that the old days were simpler than they really were. They were just as complicated as things are today.
I think we should go and ask you, what would you say that is the most important? Is it in software products? Is it standards or state of the art?
Well, as you move into the center of the system, like the microprocessor itself or the operating system, being a standard gets to be awfully important because that, by having a standard there, you allow people to write their applications only once and use multiple applications with one operating system. When you get out to the applications themselves, then the key issue is being state-of-the-art, you know, being the easiest to use and the most effective. Even there, some companies have gotten a lot of market share because once a lot of people learn an application, they tell their friends about it, and books are written about it. So even there you have sort of standards. They're not really standards, but take like 1, 2, 3. In the character mode of spreadsheets, it became very popular. And it's really only the transition to graphics interface that's creating an opportunity, or might create an opportunity, for somebody like Microsoft with Excel to get in and change that standard.
Would you also say that being backed by a large company such as the IBM was crucial for this?
Well, I think because IBM is successful in large computers, people assume that they necessarily were going to be successful in PCs. I had more people working on the IBM PC than IBM did. Likewise, when the Macintosh was being developed, I had more people working on the Macintosh software than Apple did. And IBM was not destined to be successful. It was really because it was a 16-bit computer, because they worked with the dealers, that they were able to be successful. Now, as we're in today's environment, where PCs are being integrated together with large machines, and you have issues of security and database management, now it's good to be working with IBM because they're one of the companies that can bring those elements together. But back then, no, it really wasn't the key issue, and I think their success is partly due to that partnership, not because they would necessarily have been successful.
So how do you see the future for MS-DOS? Will it remain the standard for microcomputers besides systems like Unix and OS/2?
Well, the MS-DOS is today on over 30 million systems, and there's far more software for MS-DOS than any other system. There's actually more money spent on MS-DOS computers than all other computers put together. And so it has a life of its own. It's a great standard. It is starting to show limits, the memory limit, the lack of a standard user interface, the lack of graphics capabilities. And so people are thinking, hey, they want something better. We give them two paths. They can buy Windows, which is an optional add-on, or they can move up to OS/2. And OS/2 is very powerful, but it takes a long time for people to switch. You have to get more powerful hardware. You've got to get the applications done. People have to start to feel comfortable with it. It takes a lot of years. And even though we're the most experienced at this, we underestimated how long it would take to get all those pieces together. I don't think many people would argue that OS/2 will succeed DOS, but it's very difficult to figure out how soon. We expect we'll sell over 1 million copies next year, but even I would say it would be 3 to 4 years before OS/2 will sell more copies than DOS will, and we'll be selling copies of DOS for 10 years, it's safe to say. We would really like to get those DOS users to use Windows, though, because even for a first-time user, we think graphical interface is such a benefit in the consistency and richness and all those things. So, you know, we're going to push to get people at least over to Windows and up to OS2 if we can.
Many people are saying that Unix is the operating system of the future and not MS-DOS. Would you care to comment on that?
Well, Unix is not a system. There's hundreds of incompatible Unix systems. There are more flavors of Unix than there are all other operating systems put together. And one thing that's important to remember is that the strength of DOS and also OS2 is you can take an application, a packaged application, and put it into the machine and just run it. That's actually what's called binary, a binary standard. And it requires you to pick an instruction set. All those DOS applications in OS2 are tied to the Intel instruction set. And that's why you can go and buy a box and run it. Unix, even if they could solve their disagreements, which at best will take many years, it's a source level standard. And I'm not going to be providing secretaries with my source codes so they can recompile them and edit them and put them on their machine. So on the desktop, where you need packaged software, I don't see Unix as being a real choice because you need a stronger standard. Now when you get off of the desktop up to larger machines, Unix is destined to play an important role. How much of Unix or how much of OS2, it's hard to say once you leave the desktop. I feel very strongly on the desktop it's DOS versus OS2. At the server it's OS2 versus Unix. The key trend, which everyone would agree with, is that the operating systems from a single manufacturer will become less important, and the open operating systems, of which there's DOS, OS2, and Unix, those will become important. The exact relative roles are something the industry is figuring out.
One more question. Do you see any changes in DOS occurring in the near future? Or can we expect DOS to stay much the same as it is now, and then gradually being supplanted by the OS2?
Well, in terms of development resources, we have more development resources on OS2 than the other systems. But we are continuing to do updates to DOS. We can't make it bigger, because if we make it bigger, then we're using up memory that people want to use for their applications. We did DOS 4.0. It's got a very nice shell. We're going to make it easier for people to upgrade their DOS. We are doing a version after 4.0 that we improve the utilities quite a bit more. So we're continuing to invest in DOS. But frankly, in 2 or 3 years, I think that all DOS users will want DOS and Windows. And so maybe by combining those products, we can do something pretty nice.
Okay. I think we should go on. This interview is to be broadcast to students and people interested in the art of programming. If a student wants to work as a programmer for the next 10 years, which subjects, for instance languages, tools, disciplines, would you especially advise them to study?
Well, there's the standard things people should understand. For example, the C language, the personal computer operating systems, graphics, on the role that plays. There's also some advanced topics that will play a very strong role. Object orientation, C++ and small talk. Those are very important things. Certain artificial intelligence techniques that are not being used in software today, I'm quite optimistic will be a critical element. So things like expert systems, non-procedural languages, inference. If somebody's ambitious and they want to really innovate, figuring out how those things can apply and simplify software development are really exciting topics.
Would you then say that languages like assembler, for instance, are out?
Well, I still think it's good to learn assembler because making programs fast will always be important. Even as the chips get faster, we'll come up with applications where really clever programming to do things fast will be important. And although very little code will be written in assembler, I think by starting out and learning assembler, you give a programmer a clear sense of efficiency. You know, what is the machine really doing at the lowest level? And to understand, as they're writing programs even in C, what's going to be fast and what's not going to be fast. So at Microsoft, we do insist that everybody learn assembly language, even though only about 5% of the work we do today is in assembly language.
You stated that you've tied your line of products to the Intel processors. Would you say that is an advantage or a disadvantage? I mean, you have other manufacturers like Motorola that offer processors of similar performance. Is it a good thing to tie your products to only one type of processor?
Well, we're tying our system software strategy, DOS and OS2, to the Intel processors. Actually, the operating system is written largely in C, and in a couple of years it'll actually be completely in C, which is a portable language. So we could move it to other processors. But I think that the need for a binary standard and the fact that the Intel processors are improving so quickly argues that, you know, we should really stick with that standard. Now, if something that was 4 times faster came along, then I would have to, you know, think about it. But I don't see that happening, even though we are in a position to take advantage of it. Now, in our applications work, we do support the Macintosh very heavily, and that's Motorola processor. So our applications group is actually broader.
In Norway, we have no large software company on our own. If you are a Norwegian programmer with an ambition to make a new successful software product, what kind of product would you try to develop in Norway?
Well, it's important to decide whether you're developing a product that you're going to try to sell on a worldwide basis. You know, the risk-reward of trying to go after the worldwide market is very, very high. You know, if you make it, it's pretty incredible. There's a huge market for products that are a lot more specialized, a lot more customized, where you're working closely with a customer. And locally, there'll be hundreds of small companies that establish those capabilities, those relationships, help people work with networks that'll be successful. A few will do software that'll be used on a worldwide basis, and probably licensing it to companies like Microsoft is one way to go. You reduce some of the risk there. Somebody could decide to promote it strictly themselves, but and the reward is even higher, but that's very hard to do. The category of software I don't recommend is spreadsheet, word processing, database. You know, maybe there's some breakthrough that, you know, I'm the old guy now and some young guy will show me. But frankly, I think that that's too crowded of a field, and that field really is for the Microsofts and the Lotuses, and that smaller companies probably should focus on newer areas and more specialized areas than those.
What about expert systems?
Expert systems is an area where the technology is to a state where you can use it for very special problems now, and that's very exciting. I think the technology will improve, so even something like understanding an office work, or office procedures, which is a much broader application, it'll make sense to use expert systems for that. We have a little bit of research we're doing on that, and I think there could be a great opportunity.
You said it was possible to go to Microsoft to get a nice product. Is it easy for a Norwegian programmer or someone who has developed a nice product in Norway to go to Microsoft?
Well, it's easy to send us a letter. Is it easy to get us to say, yes, this is super great, we should license it and all that? No, it's not easy for anyone anywhere in the world. We pick a few things, you know, Flight Simulator, Mac Works, Microsoft Project. We have, I think, about 6 or 7 of our products where we licensed outside technology to create the product. And so actually the majority of what we do in-house. And nowadays, we rarely license something unless it's already running, unless we can see it concretely, because there's so many people who come along and say, I can do this or I can do that. Well, you know, how much time do you want to spend? It's better to see the thing running. So it can happen, but it has to be something really, really quite impressive. There are other companies besides Microsoft that are more focused on this idea of publishing. Publishing is not our mainstream, and so you shouldn't. Someone shouldn't send it just to us. They should send it to a number of people to see if they can really strike a resonant chord. The key thing, I think, would be to get somebody in the local group very excited and have them be your champion to carry the message in to what has become a reasonably large company.
When you develop a new product, you have to fit it to a lot of national standards. Like in Norwegian, we have these non-English letters, which cause a lot of trouble in our programs. How do you do that? I mean, do you put any effort into making your products Norwegian?
Well, if you want to sell products, it's an absolute requirement. Maybe 3 or 4 years ago, people got away without doing that, but everybody has to do that today. And in fact, if you think about that when you're first designing the product, it's really very simple. Because we use 8-bit codes, 8 bits can describe all the characters you might want to use. I mean, if we somehow had 7-bit computers, it might be a problem. But, so nowadays, we're very good about planning that in advance, including those features. Then the only thing that causes a delay is just translating all the documentation and all the help files and those sorts of things. But the provisions for the characters we make from the beginning.
Okay. William Gates, thank you for coming to this interview.
Thank you.
Programmet du nettopp har sett inngår i en serie programmer i grunnleggende databehandling. Faget er en del av NKI Datahøyskolens ADB-kandidatstudium. Vil du vite mer om dette, kan du henvende deg til NKI, postboks 111 13 41 Bekkestua. Telefon 02 12 29 50.